Let's take a look at some of the examples in the textbook that might help us to work through some basic algorithms in elementary programming. So here we have a problem statement, and again, the actual programming of this is fairly straightforward. Some of the wording might be a little bit lofty and so confusing, but here is what it says. Given the variables of taxable purchase and tax-free purchase, which already have been defined, write an expression corresponding to total amount purchased. All this means is that there's going to be a total amount, and we have to figure out what it is. So given the variable taxable purchases and then tax-free purchases, the note says the question does not follow our naming convention for variables, should have been named something else. That's okay. So in this instance, what we are really asked to do is to get a total, which means to add things together. So all we have to do, and I'm going to use my trusty copy and paste skills here, we're going to say, give me all the taxable purchases, and on top of that, let's get tax-free purchases. And so as a total, there will represent all the money that we're spending. Let's check if this is working. All right, and it looks like the solution is just fine. So notice that we're taking a small step towards programming, first by understanding the problem and then putting variables together. All right, let's look at another example. Here we are given variables of full admission price and a discount amount, and we need to write an expression corresponding to the price of a discounted admission. So let's say that a movie ticket costs $10 and you have $2 off coupon. What are you going to pay at the end? Well, let's take a quick look. We're going to take the first price. This is the full purchase. And then we have to subtract whatever the little coupon that we have. Maybe you found it in the newspaper. We put that down. And so these are basic algorithms that help you to represent real-world situations in programming. We'll go ahead and check this one as well, and we're good to go. All right, so let's continue with the next one. All right, given the variable price per case, write an expression corresponding to the price of a dozen cases. All right, so if you have price per case, perhaps you are selling apples, and a case of apples is $20. So a dozen, of course, cases is 12. A dozen is 12. So we simply are going to multiply that by 12. All right, and so again, we're taking what's known to us, and then we're creating an expression out of it. And we will submit that for a quick recheck, and it looks like we're doing okay. Let's move along. So now we have a new problem. Given the variables cost of bus rental and then maximum bus riders, write an expression corresponding to the cost per rider. All right, so you're doing a trip, maybe out to Austin, and you're going to try to get as many friends on the bus as it fits the bus. Let's say it's a bus of 40 people, you got 40 people signed up, and the bus costs $400. So how do you know how much to charge each person separately? Well, what you will do is you'll take the cost of the entire rental bus, and then you'll divide it by how many people can ride on the bus. And this will give you the price per each rider. And so we'll give that a check. And let's scroll down here. It looks just fine. All right, so moving along. Now we're going to look at a different kind of a question. Write an expression that computes the remainder of the variable principal when divided by the variable divisor. Okay, so this is somewhat of a unique question because it deals with a special mathematical operator called modulo. like this. Now, you might look at this and say, that's the percent sign. And that's true. When we are using expressions like 10% times 5, it means percent. So some portion of 100. But it's also an operator, just like a plus or a minus is an operator. And in the textbook, there is a page on that with some examples. But what it means is that when you divide 2 by 1, there is no remainder, right? Ones fit perfectly into 2's, and so 2 divided by 1 is 2. Okay, now if you were to divide 2.5 divided by 1, now you have a remainder. And so if you don't want to deal with fractions, you could say, well, I know that it will fit twice perfectly, but then the 0.5 will be the remainder. And so that is what this particular operator module is going to help us with. And in this example, we simply are going to take the main number and then take the modulus and then follow it with the divisor, or the number that we divide by. And so if you take 10 and do modulus of 3, so you try to divide 10 by 3, it doesn't fit, 3's don't fit perfectly into a 10. So 3 will be the main integer, and then the modulus, or the remainder, will be 1, right? Because we have 9 divided perfectly, and between 9 and 10 there's only 1 difference, so 1 is the divisor. So this is not necessarily a programming challenge. This is something that math brings out, and we don't use that so much, in life, other than when you go to the store, you get some change back, right? And so the remainder is like getting change back at the store. All right, so we'll go ahead and move to the next one. And in this one, write an expression that computes the average of the values 12 and 40, assign it to the variable. So what this means is that, let's say you have a 12-year-old and a 40-year-old, and you need to know what the average age is. Maybe you are trying to enter some kind of a competition, and they're saying that, hey, the average age of all the contestants has to be, say, 20. So how would you calculate that? Well, you simply would take the 12 age plus the 40, and if you have more of them, you keep adding, and then whatever you have as a total, divide that by however many numbers you added. So if I added 1, 2, 3, 4, 5 numbers, I would divide by 5. That's how you calculate averages. And so let's check that one, and we see that oh, this didn't work. Why? Because we were asked to have an average variable. There we go. So all we have to do to fix that is to say an average variable is equal to, and then calculate the average, and that agrees just fine. So that's for calculating averages. Let's go ahead and check another one. Now you are given 2 variables, both are defined. One is named price, associated with the float, and is the price of an order. And the other is total number, and is associated with an integer and the number of orders. Write an expression that calculates the total price of all orders. All right, so this is fairly straightforward, but let's talk about this idea of a float, right? A float simply means that it's not an integer, a full number, 1, 2, 3, 4, but it could be 1.3, 2.7. So floating numbers are simply ones that can have fractions in them. So 1.0 shows us that we are accounting for some floats afterwards. We typically don't use integers when we talk about things like human beings. Like, what's 1.5 human being, right? Of course, in the US, the average child or average children per household is 2.5, right? So what is 0.5 of a child? Well, so that's why we have integers. Integers means they are full numbers, and that's how we understand them. So how would we calculate this full order price? Well, we're going to take the price and simply multiply it by however many orders there are. And so if there were 2 orders and 1.5 was the price, and so the total would be 3, right? And so let's go ahead and see if that calculates. And so we have the price multiplied by however many the total numbers of the items were. All right, very nice. Moving along. Now we have another question. You are given 2 variables, both already defined. One associated with a float and named total weight, containing the weight of shipment, and other associated with an integer and named quantity, containing the number of items in the shipment. With the expression, write an expression that calculates the weight of one item. All right. So if we read this carefully, we see we have a total weight, and if we divide the total weight by however many items there are in the box, then we will know how many items there are in the box. And that is, for example, how you can calculate in chemistry the weight of particular atoms or particular elements, knowing how many there are in a total. All right, very nice. So moving along, assume there is a variable h already assigned, positive integer. Write code necessary to assign its square to the variable g. For example, if h had a number of 8, g would get the value of 64. And so what we would do here is we would have the g variable being equal to h times h. H times h is the same as square. And so another way to write that down would be h caret 2. That's h squared. But that's all we will do here. We're going to calculate a square of a particular number. All right, and we have a couple of other options of how that could have been done. And this is a nice little for loop that allows us to go through as many h's as we want, and it's going to go ahead and calculate it. All right, let's go to the next one. Now we read, assume that price is the integer variable whose value is the price in US currency in cents of an item. Assuming that the item is paid for the minimum amount of change and adjust single dollars, write an expression for the amount of change in cents that would have to be paid. Okay, so in this instance, we are going to use the price and then the familiar expression of modulus. So we are looking at how many cents need to be paid out. Therefore, we want to do clear math and complete math on all the full dollar bills. So again, if you have 9 and then you try to fit that into a 10, right? You're going to be able to fit it once, and then 1 will be left over. And so that you have to pay out as a change. So if you try to calculate that mathematically, you're going to take whatever the price may be, $10, 0.2. The 0.2 will be the 20 cents that need to be paid off. And this is what the modulus function does. We are using a couple of times this modulus function. This is just something to show you about mathematics, but it is not something you have to memorize, not something you have to practice. It's something that's there in mathematics, and that's why we have a couple of questions in the textbook that deal with it. All right, so let's look at the last item here on the list. And this one says, assume that a variable x has been assigned an integer value. Write an expression whose value is the last rightmost digit of x. Okay, and so in this instance, this is exactly what we dealt with in the previous question about cents. So we have x as the number, maybe 1.3 or 5.2, and we are trying to find the last digit. Now in decimal system, which is our numerical system is decimal system based, if you do modulus of 10, then you will end up with dividing everything by 10. and then having the remainder stay. So when it says assume that a variable x is first, and then write an expression whose value is the last rightmost digit of x, what we're saying here is that if you divide something by 10, all right, you're going to pay attention to the remainder of the last number. So for example, if we have 11 modulus of 10, the remainder will be 1. If you have 18 remainder of 10, then it'll be an 8. And so that's how modulus of 10 always gives us that last digit. So this last question simply was asking, hey, have you thought a little bit deeper about this expression of modulus? But if you guessed it and it worked, I tell you what, that's the benefit of programming, and that is you don't have to design everything from scratch. As you go, you test functions, you make them work, and the computer knows that we are far inferior, and sometimes we have to have a lending hand. Well, I hope you enjoy this, and we'll talk to you soon.